You are tuned to Iri-e-learning and I am your host, Teacher. This is the first lesson for the unit on states of matter where we will examine the evidence of matter. Check the description box for the links to all the videos related to this unit. By the end of this lesson, we should be able to define the term matter, explain the particulate theory of matter, identify processes that provide evidence for the particulate theory of matter, and identify the differences between osmosis and diffusion. Of course, if we are to learn about states of matter, one of the first things we need to know is what is matter? Matter is anything in the universe that has mass and takes up space. So two important things to remember about matter is that it has mass and takes up space. So, what does the particulate theory of matter tells us? The particulate theory states that matter consists of many particles that are in constant motion. Since particles of matter are in constant motion, then the particulate theory of matter is also known as the kinetic theory of matter. There are three everyday processes that prove the particulate theory of matter. They are osmosis, diffusion, and Brownian motion. However, in this lesson, we will only examine osmosis and diffusion. But keep in mind that Brownian motion involves the random movement of particles suspended in a fluid being a gas or a liquid. The movement of these particles results from the collision with the fast-moving atoms or molecules in the gas or liquid. A perfect example of Brownian motion is the movement of dust particles in air which becomes visible in the path of a beam of light, as observed in this video clip. So what is osmosis? Osmosis is the movement of water molecules or solvent molecules through a semi-permeable membrane from a region where there are many water molecules to an area where there are fewer or no water molecules. Let us summarize the conditions required for osmosis. 1. It involves the movement of water molecules or solvent molecules only. 2. The water molecules must pass through a semi-permeable membrane, which is also known as a selectively permeable membrane. And 3. The net movement of water molecules occurs from a region where there are many to an area with fewer water molecules. So as we can see from our illustration, the water molecules are moving from the area where there are many water molecules through our selectively permeable membrane to the region where there are fewer water molecules. It is important to note that when there is a notable difference in the number of particles or the concentration of particles between two regions, this sets up what is called a concentration gradient. And the concentration gradient drives the particles to move passively from a higher particle concentration to a lower particle concentration. In other words, we can say that the net movement of the particles is always from a region of high concentration to one of lower concentration. Now it's time to look at diffusion. And diffusion, as we know it, is the movement of fluid particles. And here again, remember, fluid means gas or liquid particles. And these fluid particles are moving from a region of high concentration to one of lower concentration until evenly distributed. And now to look at our illustration to summarize the process of diffusion. Here we have in our illustration a gray region in the center of our screen, the area of high particle concentration. As you can see, there are some red particles in that region. And surrounding it in the blue shade, there are no particles, and hence it is considered our area of lower concentration. Now the difference in the particle concentrations between the two areas sets up the concentration gradient, resulting in the passive movement of particles towards a region of lower particle concentration. And this process we know is diffusion. And eventually, of course, the particles are evenly distributed within the space. Now, there are two main differences between osmosis and diffusion. Osmosis, as we know, involves the movement of solvent particles or solvent molecules, such as water molecules, whereas diffusion involves the movement of fluid particles, gas or liquid particles, of course. And secondly, osmosis requires a semi-permeable membrane, whereas diffusion does not require a semi-permeable membrane. Let us review the lesson summary points. Matter is anything that has mass and takes up space. The particulate theory of matter suggests that particles are in constant motion, and because it's suggesting that particles are in constant motion, the theory is also known as the kinetic theory of matter. Osmosis involves the movement of solvent molecules, such as water molecules, from a region where there are many solvent molecules through a semi-permeable membrane to a region where there are fewer or no solvent molecules. Diffusion is the movement of fluid particles, such as the particles from liquids and gases, from a region of high concentration, that's an area where there are many of the particles, to a region of lower concentration, and that is an area where there are fewer or no particles. Next, we'll highlight the two main differences between osmosis and diffusion. Osmosis involves the movement of solvent particles, while diffusion involves the movement of any gas or liquid particles. Osmosis requires a semi-permeable membrane, also known as a selectively permeable membrane, while diffusion does not require such a membrane. It's quiz time! Let's see how much you understand and remember about the concepts learned. The quiz consists of 5 questions, and you have 5 seconds to answer each question after it has been read aloud. So are you ready, learners? Okay, so here we go. Question 1. Which statement best defines matter? A. Matter is anything that has weight and takes up mass. B. Matter is anything in the universe that is visible. C. Matter is anything that has mass and takes up space. D. Matter consists of a few things in the universe that have mass. The answer is C. Matter is anything that has mass and takes up space. So remember, when we're dealing with matter, look out for those two things. It must have mass and it must take up space. Question 2. We need to finish off this statement. The particulate theory of matter suggests that A. Particles move to take up all space available to them. B. Particles of matter are constantly moving. C. Particles of matter do not move. And D. A precipitate is formed when the particles of two gases meet. The answer is B. So the particulate theory of matter suggests that particles of matter are constantly moving. That's why it's also known as the kinetic theory of matter. Question 3. Which of the following processes proves the kinetic theory of matter? A. Diffusion. B. Osmosis. C. Brownian motion. D. All the answers are correct. The answer, of course, is D. All the answers are correct. So if you remember at the start of the lesson, Brownian motion was listed as a process that proves the kinetic theory of matter, even though we did not look at it in detail. Question 4. Sharon lives a quarter mile away from a bakery, yet she can smell the fantastic aroma of freshly baked bread from her home. Which of these processes describes Sharon's experience? A. Osmosis. B. Diffusion. C. Photosynthesis. D. Evaporation. The answer is B, which is diffusion. And just remember to be able to smell the aroma of anything, especially if its source is far away, it means that those gas particles are moving throughout the air. Question 5. Which statements are true about osmosis? 1. Osmosis involves the movement of solvent molecules. 2. Osmosis does not use a semi-permeable membrane. 3. Osmosis occurs when the solute particles move from a region of higher concentration to one of lower concentration. And our answer options are A. 1 only, B. 1 and 3 only, C. 1 and 2 only, D. 1, 2, and 3. And of course, our answer there is A, 1 only. Now, let us see why the other options do not apply. Option 2 is not correct because osmosis requires a semi-permeable membrane, as we know. Option 3 is also incorrect because it is solvent particles, not solute particles, that move during osmosis. We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you'll receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.